This video is concerning function mapping. Function mapping. This is a picture right here of a mapping of a function. What does that mean? It means that this is represents a relation, or in this case, a function. I'm going to zoom in a little bit to see if I can get that closer for you. All right. Now, in this case, this represents an equation somewhere, or a relation. Let's see. It says here's the x values, and all these are x's, and so we know this to be the domain. These are y. Remember, this is function notation for y. It'd be still a y. And this means if I put in this value, I get this value, because this is the range. The y value or the range. All right? This says that somewhere there's this relation that if I put in a 1 into the equation, what should I get? Well, it comes across here, and it looks as I should get a 1. So if I put in a 1, I get a 1. So that's the same thing as saying an ordered pair of 1, 1. Make sense? Yes. Okay. If I put in a 2, what value do I get? Well, according to this, if I put in a 2, I should get a 2. So here's all this relates back to ordered pairs. This is just different ways of looking at relations and determining if they're functions and how they behave. Now, this is, we've already looked at videos where we were given ordered pairs and where we were given pictures. Well, this is called a mapping, okay? And you can determine from this mapping whether or not this is a function. You can also determine how it behaves. This also says that if I put in a 3, I get a 3. So again, there's, 3, 3. If I put in a 4, I get a 4. All right? And this represents an equation somewhere. Now, as you can tell, the domain, the x values, do not repeat. In other words, there's only one arrow that comes out of each domain, and therefore that means there's only one value that's going to be a y for this particular domain. So that tells me, by the definition of a function, function is a mathematical rule that for every member of the domain, there exists only one member of the range, or one y for every x. And as you can tell, since only one arrow comes out of each number, then this is a function. And this is the ordered pair that it generates. So this is a function. Let's look at one that's not a function, okay? This one right here is another mapping, okay? It says right there, mapping functions. All right, here again, this is the x values here. These are the domain. These are the range. In other words, if I put these values in, I get these values. But now, which ones do I get? If I put in a 4, I get a 4. All right, that makes sense. And if I put in a 3, I get a 3. And again, that means 3, 3, the ordered pairs, there's the x, and there's the y. Now, if I put in a 2, I get a 2. This is just like the other one. But it says here that if I put in a 1, I get 2 different values. And we know that's not right. If it happens, that means that this is not a function. So if I put in a 1, I get a 1, which means I have 1, 1, and that looks all right. But it also says that if I put in a 1, I get a 4. See this line pointing here? So as you can tell, because of mapping, this mapping diagram, that the x's repeat or the domain repeat. You can tell that from just looking at the mapping without even writing this down. If I look here, I see that this value of the domain has 2 y values. Therefore, this is a map of a relationship, or a relation rather, that is not a function. Okay? It is not a function. All right, now let's look at 2, and I want you to help me pick out whether or not these are functions. All right, look at that mapping. All right, this is similar to the one a while ago. Here's the x values or the domain. You can tell by that. These are the range written in function notation. Now, if I put in a 1, what do I get? Well, if I put in a 1, I get a 3. If I put in a 2, I get a 3. Now, the y's are repeated, but we don't care about that. It's the domain that is the determining factor in whether or not it's a function. If you look at this, you'll see that no matter what value I put in, I only get one y value for it. because there's only one arrow that comes out of each member of the domain. So this is a function. This is a function. If I put in a 4, I get a 4. 3, I get a 5. So this is a function. All right, let's look at this one right here. All right, now looking at this one, let's determine if this is a mapping of a relation. Here's the domain, here's the range. We are concerned with the domain. If I put in a 1, I should get a 6. If I put in a 3, I get a 9. But if I put in a 2, see these two arrows coming out? It says if I put in a 2, I get a 6 and a 7. And therefore, since two arrows come out, I have two values like this. It'd be 2, 7 and 2, 6, which this means that this is not a function because the domain repeats and shows up twice. Now, sometimes we are asked to use this mapping to determine the equation that it maps with. Let's look at this. All right, this problem right here. All right, this problem right here says that if I put in a 1, let's pull this out some a little bit. There you go. All right, this says that if I put in a 1, I get a negative 4. If I put in a 2, I get a negative 2. If I put in a 3, I get a 0. And if I put in a 4, I get a 2. Now, one of these equations here is what generated this mapping. In other words, one of these equations here maps to this mapping here. Let's see which one it is. Now, to test it, I need to test all of them, but I'm going to test the easiest one first. It says that if I put in a 3, I get a 0. If I put in a 3, I get a 0. So let's try these. All right, right here. 2 times x is 3. 2 times 3 is 6. 6 minus 6 is 0. So it could be this one. If I put in a 3 right here, 3, I should get a 0. 3 minus 3 is 0. It could be this one right here. Now if I put in a 3 right here, I get negative 3. And negative 3, that's negative 6, so it cannot be this one. And if I put in a 3 right here, negative 2 times 3 is negative 6. It's negative 6 and negative 2 is negative 8, not 0, so it cannot be that one. So I've already narrowed it down to these two. Okay? Now let's pick another one. Let's pick, I like positive numbers, so let's pick 4. If I put a 4 in these two equations, and I've already eliminated these two, if I put in a 4 in these two equations, I will get according to this, a 2. Well, let's just check this one. This one's easy to look at. Let's see. Put a 4 right there. 4, take away 3, is 1, not 2. So it appears that this is not the answer. So let's put a 4 in right there. 2 times 4 is 8. 8 take away 6 is 2. Therefore, if I put in a 4, I should get, for f of x, I should get a 2. And that's what this says right here. So I'm going to check one more just to make sure. If I put in a 2, I should get a negative 2. So I'll put in a 2 right here. 2 times 2 is 4. 4 take away 6 is negative 2. So that's true. So therefore, I can tell from this mapping that this A is the answer. Okay, let's try one more rather quickly. All right. This one says right here, same logic. Which one of these equations describes this mapping? Okay, or which one? This mapping describes one of these equations. So let's word it like that. All right. As you can see, this is a function because only one arrow comes out of each one, but it says it's a function. But which one of these equations represents that? Well, let's take the easiest one. If I put in a 0, I should get a 3. If I put in a 0, I should get a 3. All right, let's try it. 0 plus 2, that's 2. It can't be that one. I'm supposed to get a 3. If I put in a 0 right there, 0 minus 1 is negative 1, so it can't be that one. If I put in a 0 there, there's no such thing as a negative 0, so I have 0 plus 3. I get a 3, so it could be that one. All right, let's try this one right here. If I put in a 0 right here, I get negative 2 times 0, 0. 0 plus 2 is 2. So that eliminated all of them but the correct answer. Now let's check and make sure that this is the answer, okay? Let's do an easier one. 1, if I put in a 1, I should get a 2, correct? If I put in a 1, I should get a 2. Let's see. Put in a 1, make it negative. So I have negative 1 plus 3. Well, 3 positives and 1 negative make positive 2. So therefore, whenever x equals 1, y equals 2. So this is the answer right here. This mapping represents this equation. This is a mapping that represents and shows what's going on in this equation. This is called mapping. Okay, we can use it to determine whether or not a mapping is a function or just a relation, and we can also use it to determine what equation it matches up to.